thank you all of you for being here. I would like to thank the organization for the invitation and the hospitality. It was very nice. Well, the title of my presentation is Attacking the Baseband Model of Mobile Devices, of mobile phones, to breach both user privacy and network security. This is a joint work of myself and my colleague, Christos Dadoyan. The outline of my presentation, first of all, we will see some issues regarding the status of mobile devices that is known the situation. We will see the mobile malware, the motivation. We will explore the motivation for this work. And then we will see the proposed malware, which is its name is UC Monitor. We will explore its functionality, architecture, prerequisites, detectability, that is undetected up to now, the impact and the criticality, as well as the white hat usage, because we have designed for this case. Currently, cyber attacks are shifting to mobile device. We're wondering why. The reason is that these devices are always on and connected. They contain very valuable and critical information. Their processing capabilities and storage capabilities are equal or sometimes better than our PC. My phone is better than my laptop. And there's a high penetration to the population. Here you can see all the interfaces that a mobile device has: GSM, 3G, LTE, Wi-Fi, Bluetooth, and near-field communication. Mobile devices also contain critical data. They include emails, documents, photos, videos, geolocation information. They include also contact details and other lists, SMS messages. We have critical applications that run on mobile devices, such as mobile banking, mobile wallet, mobile visa, VPN client, cloud storage and cloud service, password managers. And finally, the telephone as itself contains critical information such as the identity of the telephone, the SIM card that characterizes us, and also your mobile number. As I said before, nowadays the mobile phones are better in processing capabilities and storage capabilities than computers. Now, let's see some statistics which have very meaningful result. Up to now, on Earth, we are 5.2 billion citizens. So, from these citizens, 3 billion have access to the internet, and 3.6 billion has mobile device, has mobile phones. So, you can see that the population of the people that has mobile phone is more than this that has access to the internet. From this, if we see the 3.6 billion that has access to my mobile phones, we have 7 billion of SIM cards, which means that we have the population of SIM cards is equal to the population of the citizens of Earth. So we can see that there is a factor of 1.94 SIM card per person. In these figures, you may see the internet, the penetration of these two technologies. We can see in Europe, we have the penetration about 82% of the internet, but the penetration of mobile devices, 125, if I'm correct, because I cannot see in both screens. So you can see the penetration is extremely high. Here is another figure that shows to us that it took 22 years from the day of the emergence of the first malware in PC to reach an upper bound, a limit of 2 million malware, but from the same in mobile device, it took us less than 10 years. So the increase is sharper. And here are some last statistics that the last quarter of 2014, we reached more than 6 million unique mobile malware. And you can see the distribution, about 7 to 800,000 per quarter, new mobile malwares. Let's see the evolution. First, in 2004, we have the Bluetooth worm, the first mobile malware. Then we have the MMS spreading. Through the MMS system, the malware was spreading. After that, between 2006 and 2008, the criminals targets to earn money. How? There were dialers or some services like sending some SMS services that charge us, and they earn money. After that, we have botnets on mobile devices. Later, we have organized crime. Currently, we have ransomware and cyber war. Everybody knows ransomware. There are many, many victims worldwide. And a question is, what's next? My personal belief is that Internet of Things, all the connected devices that we have in our home, in the industry, in our environment, how we communicate with our car, and all that stuff. So, the motivation for this work was, okay, up to now, the majority of the mobile malware targets and exploits the vulnerability of mobile operating systems and targets, let's say, the level of application, what we run on our mobile devices. We try to think a little different, and we have seen that, to the best of our knowledge, there is no mobile malware that targets the modem of mobile devices, in order to breach the privacy of mobile users and the security of the cellular networks. If we see the architecture of mobile device, you may see that we have two processors. One, this processor runs all the application, and here executes the operating system, the Android, the iOS, the BlackBerry, and all that stuff. And there's another processor there that communicates with a radio interface, communicates with a mobile operator. So we have two different processors. So we have designed and implemented a new type of mobile malware for both Android and iOS that targets, as I said, the mobile modems. What was the goal? What is the goal of this malware? Is to steal security credential and sensitive information of the cellular technology. And what is this? It's identities, encryption keys, and location of the user. This links provides you the software that we have provided. We have uploaded to the GitHub, is an open source software, and these are two screenshots of our malware, of our application, of our utility that we have designed and implemented. This runs on an Android telephony, and this runs on an iOS. I have these two telephones here to show you after the presentation how the malware runs. Through 80 commands, using 80 commands, our malware targets and gets information from the USIM or the SIM card, it depends on your subscription, that you have on your mobile device. Every subscriber has a SIM card to put in the mobile device and then has his subscription on the device. So we use 80 commands to steal or to get encryption keys, key threshold and cipher indicators, identities, the network type and the network provider, location area identity, routing area identity, as well as the cell ID. And all this information that is extracted is uploaded to a server. 80 command is a command language, a very old language that has been used since 1981. actually is the command language that enables a processor to communicate with a modem. Both Android and iOS use such commands to communicate with the modem, the baseband modem of mobile device. This language, this type of language, manages call control, data control, network service control, SMS control, and data retrieval. We use this last type of AT commands to get this information. This is the categories, the 3 categories of AT commands that we use in our malware or in our application. And this is an example of how an AT command takes place in order to get the IMSI, the identity of the user from the SIM card. Now, this is an architecture of a mobile phone. We exploit this particular entity, which is a radio interface layer. It's an API, it's a layer that enables the communication between the applications and the telephone to the SIM card and the baseband modem. It's a specific module that enables the communication between these 2 functionalities, or these 2 entities, the applications and the telephony. So we have exploited this module. This is the architecture of our malware. We have the event listener unit. This unit maintains and captures the occurrence of an event. If you receive a call or you make a call, you screen on and off your screen, your device, power on off, or periodically. We have programmed periodically the daemon to create an instance and get this information. Then we have the data collection unit, which actually creates a system processor to evoke a Linux script to get the information. This module also gets the information from the modem. We have the shell script that contains all the commands that we want to run, to execute, to take the information from the SIM card. Of course, the SIM or USIM card that contains all the valuable information. We have the data parsing unit, which filters the information, discards the unnecessary, the information that we don't want, and keeps only the meaningful data. And this information also stores the data to a local database, as well as has a functionality to show this information to our screen in case we want to see this information. And finally, we have the upload unit, this unit that uploads this information to a remote server. Now, a prerequisite to our application, to our malware, to our piece of software, is to have root privileges. It is necessary for the device to be rooted. Okay, we have many devices are rooted, since they give more flexibility to the users, or we may include a specific payload in order to root automatically the device that we would like to infect. Our piece of software is transparent. We cannot notice it if we see how our phone operates, and it's stealth. Up to now, we cannot recognize with any measure. To prove this, we have tested our application, our piece of software, with 5 very famous and well-behaved antivirus products. And the result was 0. No one detected it. Because the AT commands are used by the telephone. So we use the same API that the telephone use. So we propose that all the antivirus software should include the syntax of specific AT commands in order to see if something like that happened in our phone. Now, let's see the impact and the criticality of our malware. Since you have the identities of the user, you may identify him. if you have the location or the routing area and the cell ID parameters, you may approximately track the victims. Then, if you have the encryption keys, you may disclose all the phone calls and the data session that the user has done. Actually, it eliminates the effort to break the algorithms. It's not necessary to, let's say, break the encryption algorithm, because breaking an algorithm is very, very, very hard process. We have the keys. We know the algorithms, so we can decrypt the information that's transmitted. And also renders inadequate all the sophisticated encryption mechanism and encryption procedures. Because if you have the key, you have everything. Now, that was the black hat use. We have also a white hat use. And this is the reason that we have invested and developed this piece of software. Actually, with this software, we capture and analyze the security policy that a cellular operator provides. What is the security policy? Is cipher disabled or not? How often an encryption key is refreshed? We have seen in Greece that one provider used an encryption key for many, many calls, 16 calls. This is vulnerable. While another one use it in every call, change the key. So we capture the security policy. Or another question is how often the temporary identities are updated. So all this information may provide it to the user to see how secure is the network operator, how the security policies approach high standards. So we can use this piece of software to inform the user, to the user to be aware about the security measures that a provider enforce, and as a ethical pen testing to evaluate the security of the networks. Here we have a very short video that shows the functionality. Can we have the video? Thank you. We enable power on, and this is the monitor. We have created an application. So when you press the button, after some seconds, but all of this can be run on the background without a notice. Here we see all the information. This is kappa C, is the GSM encryption key, GPRS key, UMTS keys, encryption integrity, the temporary identity, the location area of the user, all the security sensitive information that is included in a mobile phone. It's a UMTS network, Cosmote, provider, Greek. And I have here two devices, this one actually, that I have put the software to run here in Estonia. We have the same result. And also here, I hope to run again. Here is the iOS that runs. We have different interfaces. We didn't spend a lot of effort to design the user interface. So, thank you very much. Questions?
All right. We have time for questions. If audience or other speakers have any questions, okay, there is the first one. Please.
Hello, thank you for the presentation.
Can you The name and affiliation.
My name is Efraim Katı. I'm from Turkish Army. And the first question is that information is enough to create another clone copy of the SIM card?
Yes.
And my second...
we need also, we need another thing also, another key that is embedded in the SIM card, but we have done this. We have done this.
That makes this process very critical.
Yes.
You can create the clone of the SIM card, and then you can interrupt banking information, 3D secure and something like that. And my other comment on the mobile security is the main issue, everybody is running as an administrator on the mobile devices.
Yes.
Most of them. And if Android and the iOS builders can design a limited user and the administrator user implement at the same machine differently. In this case, when the users use their devices as a limited user, then they will be protected from the most of the malwares, I think.
Yes, the answer is yes, because if you have noticed to a previous slide, there is a radio interface layer that if the device is root, we have access to this particular module. But this is actually a feasibility study. Since we, with no funding, we could create this based on the work of master students. We are a public university with no money we have spent nothing to do this. If you have a lot of brilliant minds and money to spend, and you may hack or take under control of this device, you can do whatever you have done, and perhaps more. This is a feasibility study. We didn't create a malware to spread it. We have studied the architecture, and we have concluded to some specific results. We have used this piece of software to evaluate the security of the operator. That was our initial and the final objective, our goal. But we saw also the malicious, and that's why we inform the community.
Right, thank you.
Hi, I'm Pekka Viitasalo from Nixu Corporation. Just a question about the SIM security. As far as I understand it, if we have a SIM card and we can send it up to commands, it actually responds and reveals these encryption keys. So I'm just wondering about the SIM security model, if it's adequate for this. Because it probably shouldn't reveal the keys, but it should only use the keys for operations.
It is not the key of the SIM card, one key that is built the whole security of the operator. It is the encryption keys that after each authentication procedure, the SIM card creates and gives these keys to the modem to encrypt our data.
Okay, so it's not the SIM card that actually encrypts it.
No, it's the encryption key, not the identification key. This is another part. But is currently the keys that usually after some calls change and the modem use. So we have exploited the normal operation because the modem asks from the SIM card the key and takes the modem and encrypts the data. We have intervened to the normal operation. This is the normal operation. That's how I said that it's a proof of concept. What might happen? It's easier to target where the key is stored than to break the algorithm. It's my, let's say from the security point of view as a teacher, as an academic staff, my perspective, my thing. I believe that we should try to protect the keys, not the algorithms so much.
All right, thank you.
Because you target you have to target the easiest chain, the easiest part of the chain, and the most vulnerable. Okay, thank you.
Great. Thank you. Any other questions? Okay, there.
Nikolaos Stamatelatos from HNDGS Cyber Defense Directorate. My question is about, have you done any research on how to infect a cell phone with your malware?
No.
No.
We have installed this piece of software to our devices in order to see how it... we have designed this piece of software since 2012, and we have used it for 2 years to evaluate the security of the operators.
Any other questions? All right, let's take maybe 2.
Thank you for your presentation, Professor. My name is Edwin Hofte, MOD Netherlands. You've probably heard about Gemalto hack.
Yes.
Okay. Are you being inspired, or did you make a comparison with it?
No.
Well, short answer.
As I said, we have used it to see. Our main interest is to the security of mobile networks. So we haven't done any work on comparison of the SIM cards or to spread this as a malware. And that's why 2 or 3 persons has all this know-how. Up to now that we have uploaded it, and we have informed everybody.
Thank you. Maybe one more question, if there is anyone. Well, I have one question. How did you test this? Or how have you tested this?
We have tested the functionality for about 2 years because we try to make experiment in the area of Athens and Greece, and we have noticed many problems, and then we come back again and again, and finally it took us about 2 years to finalize another job, another work on the evaluation of mobile networks. It's a war driving of 3G technology. It's the first job, such a job, and we have submitted to a highly valued international journal, and we expect their comments and their results.
All right, thank you. Let's end here. I have a small gift for you.